Hi guys, it's me Jasper Pulgo. In continuation to the previous discussion of the reporter, I'm going to give an example of unconsolidated undrained problems. So let's go. An unconsolidated undrained triaxial test is performed on a sample of saturated clay with a cell pressure of 100 kilopascals. The sample fails when the applied axial stress reaches 250 kilopascal. Calculate the following. First, angle of shearing resistance. Second, the endrained shear strength of the sample. Third, the normal stress at failure. And lastly, if a second UU test was performed on an identical sample at a cell pressure of 200 kilopascal, would you expect the undrained shear strength to increase, decrease, or stay the same? Okay, let's start to comprehend our problem first. So, we have here a triaxial shear test, and this is an unconsolidated undrained triaxial test because the drainage valve here is closed. And let's dissect the problem first. The sigma 3, which is the cell pressure of 100 kPa, and our sigma 1 is the axial stress, which is 250 kPa. And let's start answering now. Okay, the first thing to do is to locate the major principal stress and minor principal stress. The major principal stress, which is the sigma 1, is located here, 250, based on the problem. And the minor principal stress is 100. And after locating these two, we're going to create a circle out of it, which intersect these 2 points, 100 and 250. So here, after creating a circle, we all know that a circle has a radius. And here we have the value of angle here. And the angle here, which is the twice the angle of the failure, plane failure. So here, 2 theta. And to get the value of theta, we have a formula which is theta equals 45 plus phi over 2 here. And we all know that in unconsolidated, undrained, triaxial shear test, the value of phi is equals to 0. Therefore, we substitute the value of phi, which is 0, to the main formula. 45 plus 0 over 2 is equals to 45. Therefore, the angle of internal friction is 45 degrees. That's the answer of our first question. And then the second question is, we're going to find the maximum shearing resistance, which is here, the R. So to get the value of R, we will get first the diameter. And after getting the diameter, we'll divide it by 2 because R equals to diameter over 2. So to get the diameter, 250 minus 100 is equals to 150 kilopascal. And after that, 150 divided by 2 is equals to 75 kilopascal, which is the value of our R here, as you can see. And this is our SU. SU, or the maximum shearing force. Here, we all know from 0 to here, which is the value of R, that's our maximum shearing force, which is 75 kilopascal. And that's the second question of the problem. And then the other question, the third question, is to locate the normal stress at failure. So this is 0 to 100, right? This is given based on the problem, which is the minor principal stress. And to get here, this is our point where the failure begins. So therefore, the normal stress is located from here to here. Therefore, to get that normal stress, we will just simply add 100 plus 75. Therefore, 100 plus 75 is equivalent to 175 kilopascal, which is our answer, final answer for that. And that's the ABC. And we're going to answer next the letter D. So, the letter D, if a second UU test was performed on an identical sample at a cell pressure of 200 kilopascal, would you expect the undrained shear strength to increase, decrease, or stay the same? So, important reminder again, in unconsolidated undrained triaxial test, it is always that the angle of friction is equivalent to 0. So, here, the first test, for instance, we have here a first test. And then, we go another, we create another test. And then, another test again. And since the angle of friction is equals to 0, therefore, there's no change of maximum shearing resistance. Right? It always, the failure envelope touches the circle only once. So, this is the tangent point, and tangent point. Therefore, the angle of friction, right, is 0. Therefore, since from 0 to here is uniform continuously until infinity, as long as the specimen is the same, then we can say that the undrained shear strength to the undrained shear strength in UU test is always the same, stay the same. Therefore, it will stay the same. And that's all. Once again, thank you.